I explained first order and first degree differential equations, previous questions and concepts. Today I will explain higher order differential equations, ordinary differential equations of higher order, that is second unit of ordinary differential equations and vector calculus. So what are the topics in second unit? So see here. So topics of unit 2 are linear differential equations with constant coefficients, and method of variation of parameters. Next, equations reducible to linear ordinary differential equations with constant coefficients. That means linear differential equations with variable coefficients. How to reduce linear differential equations with variable coefficients with the constant coefficients. Applications, electrical circuits. So first definition, homogeneous linear differential equation. So how to write the homogeneous linear differential equation? So an ordinary differential equation of the form. So what is the equation? A0 into nth derivative plus a1 into n minus 2 derivative plus a2 in n minus 1 derivative plus a2 into n minus 2 derivative of y plus on plus an into y is equal to 0. Here what is this? RHS is 0. So this equation is called, and in this equation a0, a1, a2, so on, an are the constants. So then we say that this equation is called a homogeneous linear differential equation with constant coefficients. So this is the standard form of a given differential equation, standard form of a homogeneous linear differential equation. And here use one operator D. So what is capital D? Where capital D is the differential operator. So how to apply this operator to given differential equation? Suppose if we consider, and if we denoting d by dx, d square by dx square, d cube by dx cube, etc. so on, by d by dx is capital D, d square by dx square is capital D square, d cube by dx cube is capital D cube, etc. so that. So and if this d by dx is equal to capital D, then dy by dx is equal to capital Dy, d square y by dx square is equal to capital D square y, d cube y by dx cube is equal to capital D cube y by d cube y, etc. So if we apply these operators to this differential equation, now that differential equation can be written as, so that equation can be written as a0 into capital D power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 so on plus an whole into y is equal to 0. So this is the operator form of a homogeneous linear differential equation. Simply how to write this equation as f of d into y is equal to 0. What is the f of d here? Where f of d is a0 into d power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 so on plus an. So this f of d is a polynomial in D. So this f of d is a polynomial in D. Now simply how to denote the linear homogeneous differential equation? F of d into y is equal to 0, where f of d is a polynomial in D. So and here capital D is equal to d by dx is known as differential operator, where capital D is called the differential operator. So next, if it is a f of d into y equal to 0 is a homogeneous linear differential equation, how to find its general solution? General solution of f of d into y is equal to 0. So how to find out the general solution? The homogeneous equation. So this is the homogeneous equation. Simply we can write this equation as f of d into y is equal to 0. So how to solve this homogeneous differential equation? By considering the algebraic equation. That means replacing d by m in f of d and solving the algebraic equation. What is that algebraic equation? Is f of m is equal to 0. So if we replace, and we know that from this notation f of d is a polynomial in D, and replace d by m in f of d and equate that algebraic equation f of m equal to 0. So if it is a polynomial of degree n, and from this equation, algebraic equation f of m equal to 0, we get m roots. So that means here the general solution is totally depending on the nature of the roots of the algebraic equation. So that is the general solution of equation 2 depends upon the nature of the roots of auxiliary equation or algebraic equation. So in that f of m equal to 0, here f of m is a polynomial equation of degree n. If we solve that polynomial equation, we get n roots. So what are the roots? Consider m1, m2, so on, mn are n arbitrary roots of the algebraic equation. And if the roots are so, the general solution is depending on following 4 cases. So what is the first one? Case 1 is when the roots are real and distinct. So there exist n roots. So here when the roots are real and distinct, how to write the general solution? Suppose if roots m1, m2, so on, mn are n roots are real and distinct, then the solution, general solution of given equation, what is the given equation? Homogeneous linear differential equation is given as, so this is solution, y is equal to c1 into e power m1x plus c2 into e power m2x plus c3 into e power m3x plus on plus cn into e power mnx. Observe clearly, in this equation there are n arbitrary constants are there, c1, c2, c3, so on, cn. So therefore this is the general solution of a given homogeneous differential equation when the roots are real and distinct. So this is the formula to write the general solution of a homogeneous linear differential equation when the roots are real and distinct. Next, second case, when the roots are real and repeated. So here also assuming that suppose first 2 roots m1, m2 are real and equal, and remaining n minus 2 roots from m3, m4, so on, mn are real and distinct. So in this case, how to write the general solution of homogeneous linear differential equation is, so here for the repeated roots, this is the general solution part. What is the general solution part? c1 plus c2x into e power m1x. So this is the general solution part, corresponding part of the repeated roots. And from this one, c3 into e power m3x plus c4 into e power m4x plus on plus cn into e power mnx is the remaining part for the distinct roots. Suppose if we take from the first 2 cases, suppose if m is equal to 1, 2, 3 are the 3 roots are real and distinct. In this case, how to write the general solution part? Y is equal to c1 into e power x plus c2 into e power 2x plus c3 into e power 3x. This is the general solution for the roots 1, 2, 3. Here roots are real and distinct. Suppose if we consider m is equal to 2, 2, 3, 5, 6. There exist 5 roots. Out of 5, first 2 roots are equal. Next 3, 5, 6 are distinct roots, but all the roots are real roots. So in this case, how to write the general solution? So for the repeated roots, how to write? Y is equal to c1. So this is the corresponding part, c1 plus c2x into e to the power 2x plus. Next 3 roots are distinct roots. And using the previous case, so how to write? That is equal to c3 into e power 3x plus c4 into e power 5x plus c5 into e power 6x. This is the procedure to write the general solution when the roots are distinct, when the roots are repeated and distinct. So this is the solution of a given differential equation. Next, third case is when the roots are complex and distinct. So how to state this one? Suppose 2 roots m1 and m2 are complex roots. So consider m1 is equal to alpha plus I beta. If alpha plus I beta is one root of the equation, one root of the polynomial equation, then its conjugate. What is the conjugate of alpha plus I beta? Alpha minus I beta is also a root. So there exist two distinct roots, m1 is equal to alpha plus I beta. If m1 exists, then automatically its conjugate alpha minus I beta is also a root. Let us denote that is m2. So these two roots are complex and distinct roots. Remaining n minus 2 roots, m3, m4, so on, mn are all real and distinct. In this case, how to write the general solution of a homogeneous differential equation? So first, for first complex roots, this is the corresponding general solution part. What is that one? E power alpha x into c1 cos beta x plus c2 sin beta x. That is the corresponding part of the general solution when the roots are complex and distinct. And what are the remaining n minus 2 roots are real and distinct. So therefore, what is the remaining part? C3 into e power m3x, C4 into e power m4x, so on, plus Cn into e power mnx. This is the formula for when the roots are complex and distinct. Similarly, when the roots are complex and equal. So when the roots are complex and equal, suppose if we take m1 is equal to alpha plus I beta is repeated 2 times. Therefore, its conjugate. What is the conjugate of alpha plus I beta? Alpha minus I beta. Alpha minus I beta also a root and which is also repeated 2 times. So let us denote that one is m3 and m4. m3 is equal to m4 is equal to alpha minus I beta. That means first 4 roots are complex and equal and remaining n minus 4 roots are real and distinct. In this case, how to write its general solution part? So this is the general solution part. So for the repeated roots, how to write? E power alpha x into c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. Here e power alpha x is common from here to here. Next, remaining n minus 4 roots are real and distinct. So what is the corresponding part? That is c5 into e power m5x plus c6 into e power m6x plus on plus cn into e power mnx. So these are the rules when the roots are real and distinct, real and repeated, complex and distinct, complex and repeated. So what are the previous questions? See here. So these are the questions. Solve differential equation d square plus 2d plus 1 into y equal to 0. Solve d square minus 4d plus 3 into y equal 0. These are the short answer questions. Okay, so how to solve these differential equation? But differential general solution of a homogeneous differential equation is totally depending on the roots of the auxiliary equation. So what is the first question? Solve d square plus 2d plus 1 into y is equal to 0. So if we consider is equation 1, yes, equation 1 is of the form. So what is the form? Equation 1 is of the form f of d into y is equal to 0. So is a homogeneous linear differential equation. So if we compare equation 1 with the standard form, where what is the f of d? Where f of d is equal to d square plus 2d plus 1. So how to find its general solution? So to write the general solution of homogeneous linear differential equation, consider auxiliary equation. So what is the auxiliary equation? Replace d by m in f of d and equate that equation, that polynomial to 0. That means solve that algebraic equation. What is that algebraic equation? F of m equal to 0. So consider algebraic equation. What is algebraic equation or auxiliary equation? F of m is equal to 0. So what is the f of d? D square plus 2d plus 1. Replace d by m in f of d. So from this equation we get m square plus 2m plus 1 is equal to 0. M square plus 2m plus 1 is equal to 0 is nothing but m plus 1 whole square is equal to 0. So from this what are the roots? M is equal to minus 1 comma minus 1. After finding the roots, write its nature. What is the nature? Here roots are real and equal. When the roots are real and equal, how to write its general solution? So therefore, general solution of equation 1. So, general solution of equation 1 is here roots are real and equal. So, follow the second case. So, that is what is the general solution? Y is equal to C1 plus C2x into e to the power minus x. So, this is the required general solution of a given differential equation. This is the short answer question. So, just to find the roots, how to write the general solution of a homogeneous differential equation? First, write the standard form and consider the auxiliary equation, find the roots, and using the nature of the roots, write its general solution. So, this is the general solution. Y is equal to C1 plus C2x into e to the power minus x. Yes, dear students, please try to solve this equation and post your answer in chat box. And what is the second question? D square minus 4d plus 3 into y is equal to 0. So, consider is equation 1. So, what is a homogeneous differential equation? Linear homogeneous differential equation is of the form. Equation 1 is of the form. What is the standard form? F of d into y is equal to 0. So, here if we compare equation 1 with the standard form of homogeneous linear differential equation, where what is the f of d? F of d is equal to d square minus 4d plus 3 is equal to 0. So, to write the general solution of homogeneous linear differential equation, consider which equation? Auxiliary equation. Now, here consider auxiliary equation. What is the auxiliary equation? Auxiliary equation is f of m is equal to 0. What is the f of m? Just replace d by m in f of d and solve that algebraic equation, that is m square minus 4m plus 3 is equal to 0. So, how to find the roots? Which can be written as m square minus 3m minus m plus 3 is equal to 0. 3 ones are. Okay. So, that is which is equal to, if we take m is common from the first two terms, m minus 3. Next, if we take minus 1 is common from the next two terms, that is m minus 3 is equal to 0. Again, if we take m minus 3 is common, what is the remaining term? M minus 1 is equal to 0. So, which is from this one we say that m is equal to 3 comma 1. These are the roots. And what is the nature of the roots? Here 3 comma 1 are real and distinct. Real and distinct. When the roots are real and distinct, how to write the general solution? It follows case 1. What is the case 1? So, therefore, general solution of equation 1 is y is equal to, when the roots are real and distinct, y is equal to c1 into e power 3x plus c2 into e power x. We can also write, so we can also write this one as r y is equal to c1 into e power x plus c2 into e power 3x. You can write in any order, that is our choice, but both are correct. Both the forms are correct. So, this is the general solution of a given differential equation. This is the solution. So, here homogeneous differential equation solution is totally depending on roots of the auxiliary equation. Next question, find the solution of the differential equation d square plus 4 into y is equal to 0. So, what is the given differential equation? D square plus 4 into y equals 0. Let us consider is equation 1 and write the standard form of equation 1. Equation 1 is of the form. Equation 1 is of the form. What is the standard form? F of d into y is equal to 0. After writing into the standard form, where? What is the f of d? Where f of d is equal to d square plus 4. So, after writing the f of d, next to find the roots, consider the auxiliary equation. So, what is the auxiliary equation here? Auxiliary equation is obtained by replacing d by m and equate to 0. Consider auxiliary equation. What is the auxiliary equation? F of m is equal to 0. So if we replace d by m in f of d, m square plus 4 is equal to 0. So from this equation, m is equal to plus or minus 2i are the roots. So here the roots are, which is of the form alpha plus or minus I beta. That means roots are complex. So roots are complex and distinct. Roots are complex and distinct, and if we compare the roots into the standard form alpha plus or minus I beta, here what is alpha? 0. Beta is equal to 2. Here alpha is equal to 0 and beta equal to 2. When the roots are complex and distinct, how to write the general solution? So therefore, general solution of equation 1 is, it follows third case. So general solution of equation 1 is y is equal to e power alpha x. What is alpha here? 0. 0x into c1 cos beta x. Beta, what is the beta here? 2. So cos 2x plus c2 sin 2x. But what is the e power 0? E power 0 is 1. So that is equal to, so that implies y is equal to c1 into cos 2x plus c2 into sin 2x, which is the required general solution of a given differential equation. From this topic, these are the only short answer questions. So this is the required general solution. Next, find the general solution of 4d square plus 4d plus 1 into y is equal to 0. So is a homogeneous differential equation, and consider it is one. Equation 1 is of the form. So equation 1 is of the form. Yes, what is the standard form? F of d into y is equal to 0. Yes, where? What is the f of d? Where f of d is equal to 4d square plus 4d plus 1. So this is f of d. And next, finding the roots. So how to find out the roots? Consider auxiliary equation. So what is the auxiliary equation? Consider auxiliary equation. Auxiliary equation is f of m equal to 0. Replace d by m. So that is how to write, which is equal to 4m square plus 4m plus 1 is equal to 0. So and this left side is of the form, which is of the form standard form, that is 2m plus 1 whole square is equal to 0. See here, a plus b whole square form, a square, 2 square, 4m square, 4m square plus 2 2 is 4m plus 1 square is 1. So directly write this one as 2m plus 1 whole square is equal to 0. That means what are the factors? 2m plus 1 into 2m plus 1. If we equate each factor to 0, from this one we get what are the m values? M is equal to minus 1 by 2 comma minus 1 by 2. After finding the roots, write its nature. What is the nature? Here m equal to minus 1 by 2 minus 1 by 2. So these two are real and equal. When the roots are real and equal, how to write the general solution? So therefore, general solution of equation 1 is y is equal to, here what is the nature? Roots are real and equal. So it follows second case. So that is c1 plus x into e to the power minus 1 by 2 into x, which is the required general solution of a given differential equation. At last, put your answer in box. This is the required general solution. So these are some questions, repeated questions. Next, how to solve a non-homogeneous linear differential equation. First of all, what is the standard form of non-homogeneous differential equation? An ordinary differential equation of the form f of d into y is equal to q of x. What is the homogeneous differential form? F of d into y is equal to 0. But here q of x, RHS is a function of x, then it is called a non-homogeneous linear differential equation where f of d is a polynomial in D, that is a naught into d power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 so on, and here a naught, a1, a2 all are the constants. So then this equation is called a non-homogeneous linear differential equation of order n with constant coefficients. This is the standard form of a non-homogeneous linear differential equation. So how to write its general solution? General solution of non-homogeneous differential equation is in two parts. So how to write the general solution? General solution is equal to complementary function plus particular integral. So these two terms are very important, complementary function plus particular integral. What is a complementary function and how to find the complementary function? See here, where complementary function is nothing but general solution of homogeneous linear differential equation. If f of d into y is equal to q of x is a non-homogeneous differential equation, complementary function is obtained by putting q of x is equal to 0. So that is f of d into y equal to 0. That means general solution of a homogeneous differential equation is called the complementary function is obtained by putting q of x is equal to 0. So, and what is a particular integral? Particular integral is nothing but is any particular solution. Already we know that what is a particular solution is obtained from the general solution by giving some particular values to arbitrary constant, that is called the particular solution. So is any particular solution of the non-homogeneous differential equation, and this particular solution does not contains any arbitrary constants. Okay, how to define the particular integral? So what is the non-homogeneous differential equation? F of d into y equal to q of x is a non-homogeneous differential equation. Then particular integral is 1 by f of d into q of x. So this 1 by f of d into q of x gives the particular integral. That is how to write particular integral is equal to 1 by f of d into q of x. And what is the important key point? Here this particular integral does not contain any arbitrary constants. Does not contain any arbitrary constant. That is very important condition. And how to find out the particular integral? So here particular integral is depending on nature of q of x. So here we have some direct methods obtaining particular integral. So what are the methods? See here. When q of x is equal to e power ax. When q of x is equal to sin ax or cos ax. When q of x equal to x power m or polynomial in x. These are the direct methods. And when q of x equal to e power ax into v of x. Any function multiplied by exponential e power ax. And what is the v of x? V of x is sin ax or cos ax or x power m. And q of x, what is the last one? Q of x equal to x power m into v of x, where v of x is equal to sin ax or cos ax. So when q of x is in this form, how to find the particular integral? Okay. Yes. When q of x is equal to e power ax. So when q of x equal to e power ax, how to find the particular integral? See here, these are the methods to find the particular integral, not a general solution. And what is the general solution of a non-homogeneous differential equation? Complementary function plus particular integral. Already we know that what is the complementary function? Is the general solution of homogeneous differential equation. So here, what is the when q of x equal to e power ax, using the definition of particular integral, what is the particular integral definition? 1 by f of d into q of x. But what is the q of x here? E power ax. So now 1 by this particular integral, directly here particular integral can be written as 1 by f of a into e power ax. If you observe clearly, from here to here, what is the observation? Just to replace d by a in f of d. D by a in f of d. When it is possible, here provided one important condition. What is that condition? If it is possible only when f of a is not equal to 0. When the functional value is not equal to 0, particular integral is obtained by replacing d by a in f of d. So this is the particular integral which gives particular integral. What happened when f of a is equal to 0? So if f of a is equal to 0, f of a is equal to 0, in this case how to write the particular integral? So particular integral can be written as x by f dash of a. When we write this one, if f of a is equal to 0, if f of a is equal to 0, particular integral is x by f dash of a. That means replace d by a in f dash of d and with x. So that is, what is the formula here? When f of a is equal to 0, particular integral formula x by f dash of a into e power x. When we write this formula, here also we have one more condition. What is that condition? Provided f dash of a is not equal to 0. When it is equal to 0, particular integral does not exist. That's why this condition is very important. When f dash of a is not equal to 0, what is the particular integral? X by f dash of a into e power ax. And what happened when f dash of a is equal to 0? If f dash of a is equal to 0, how to write its particular integral? Continue this procedure. How to write? Particular integral is x square by f double dash of a. X square by f double dash of a into e power x, provided f double dash of a is not equal to 0. So if we continue this procedure, suppose in general, so rth derivative of f of a is equal to 0. General term, rth derivative of f of a equal to 0. How to write the particular integral? Particular integral can be written as x to the power r plus 1 by r plus 1th derivative of f of a into e power x. Here also provided r plus 1th derivative of f of a is not equal to 0. This is the procedure. That means continue this procedure until the denominator will be non-zero. So this is the procedure when q of x equal to e power ax to find the particular integral. Yes, what are the previous questions? See here. These are the previous questions, some questions. First question, solve d square plus 5d plus 6 into y equal to e power x. So first identify the nature. Is homogeneous or non-homogeneous? Yes. Tell me, is homogeneous or non-homogeneous? Please post your answer in chat box. Is of the form, equation 1 is of the form. Yes, what is the standard form? Is of the form. What is the non-homogeneous equation standard form? F of d into y is equal to q of x. Observe clearly, in a given differential equation, RHS is non-zero. So here, that is, what is the standard form? F of d into y is equal to q of x. Now compare equation 1 with this standard form and write the terms where, what is the f of d? Where f of d is equal to d square plus 5d plus 6. F of d is equal to d square plus 5d plus 6. And what is the RHS? And q of x is equal to e power x. Is a non-homogeneous differential equation, and here general solution is in two parts. First, to find out the complementary function. So first, how to find out the complementary function? Complementary function is nothing but is the general solution of homogeneous differential equation. That means, what is the homogeneous differential equation? By putting q of x is equal to 0. So to write the complementary function here, consider auxiliary equation. What is the auxiliary equation? Auxiliary equation is f of m is equal to 0. So auxiliary equation f of m equal to 0 means, how to write this auxiliary equation? Replace d by m in f of d and solve that algebraic equation. So how to write this one? Which is equal to, already we know that f of d. What is f of d? D square plus 5d plus 6. And how to write f of m? M square plus 5m plus 6 is equal to 0. So this is the auxiliary equation, and write its roots. Find its roots. 3 2s are, so that is m square plus 3m plus 2m plus 6 is equal to 0. Find the factors and from the factors write the roots. So next, from the first two terms, if we take m is common, so what are the remaining terms? M plus 3. Next, from the next two terms, if we take 2 is common, m plus 3 is equal to 0. Again, what is the common factor? M plus 3. If we take m plus 3 is outside, so what is the remaining factor? That is m plus 2 is equal to 0. From these two factors, what are the roots? Roots are m is equal to minus 3 comma minus 2. After finding the roots, write its nature. Why nature is important? To write its corresponding part of the complementary function, general solution or complementary function. So here, what is the nature? Roots are real and distinct. When the roots are real and distinct, how to write the general solution of homogeneous? Here observe clearly, general solution of homogeneous is called the complementary function of non-homogeneous. So here don't write general solution. So write the complementary function. So therefore complementary function of equation 1 is when the roots are real and distinct. So what are the roots? Minus 3 comma minus 2. So complementary function notation is, we can write yc. So yc is equal to, here roots are minus 3 and minus 2. So that is c1 into e power minus 3x plus c2 into e power minus 2x. Let us take is equation 2. So what is this one? Is the complementary function, that is first part of the general solution. First part of the general solution of non-homogeneous differential equation. Half part completed. What about next one? Particular integral. So how to find out the particular integral? So here particular integral is depending on RHS. So what is first? To write the definition of particular integral. So by the definition of particular integral, what is the definition? 1 by f of d into q of x. 1 by f of d into q of x. This is the definition of particular integral. Now here what is the f of d? 1 by d square plus 5d plus 6 into, what is the q of x here? E power x. And next write x coefficient. What is the x coefficient is called? A. What is the A? A is equal to 1 here. E power ax, here A is equal to 1. And if we replace, if we substitute A equal to 1 in f of d, check that is equal to 0 or not equal to 0. How to check that one? See here, what are the what are the roots? Minus 3 and minus 2. Here what is the A value? A is equal to 1. So from the auxiliary equation we have the roots minus 3 comma minus 2 and here A is equal to 1. If this A is equal to any one root, if A is equal to any one root, so then functional value is equal to 0. Here no need to check the condition, no need to substitute the A value in f of t. This is one important key point, whether functional value is equal to 0 or not equal to 0 after substituting the A value. Now see here what are the roots? Minus 3 and minus 2. Here A is equal to 1. This is not equal to any root. So therefore, if we substitute A equal to 1 in this equation is not equal to 0. See here. What is the f of d? F of d is equal to d square plus 5d plus 6. Check that. Replace d by 1. F of 1 is equal to 1 plus 5 plus 6 is equal to 12, is not equal to 0. No need to check the condition if we know this key point. Okay. So now when f of a is not equal to 0, what is the particular integral? Just to replace d by 1. So that is 1 plus 5 into 1 plus 6 into e power x. So that is equal to 1 by 12 into e power x. So this is the particular integral yp. Is equation number 3. Next, write the general solution. Solution is not completed. Next, write the general solution. So what is the general solution? Therefore, general solution of equation 1 is, what is the general solution of equation 1? Y is equal to complementary function plus particular integral. So that implies y is equal to, what is the complementary function here? See here, what is the complementary function? Yc is equal to c1 into e power minus 3x plus c2 into e power minus 2x. So which is c1 into e power minus 3x plus c2 into e power minus 2x plus particular integral. From equation 3, what is the particular integral? Plus 1 by 12 into e power x. And what is the here important key point? Particular integral does not contains any arbitrary constant. And observe clearly this general solution. Here how many arbitrary constants are there? 2 arbitrary constant. What is the order of the given differential equation? 2. So which satisfies the general solution condition. What is the general solution? A solution in which number of arbitrary constant is equal to order of the differential equation, then such solution is called the general solution. And what is the important key point in this particular integral? Particular integral does not contain any arbitrary constant. At last, if you combine these complementary function and particular integral, which gives the general solution. So this is the important, general solution part is important. So which is the required general solution of a given differential equation when q of x is exponential. Okay, next question. Solve d square y by dx square minus of a plus b into dy by dx plus ab into y is equal to e power ax plus e power bx. Okay, first write the given differential equation into operator form for our convenience. So how to write the given differential equation? So this d square y by dx square can be written as capital D square. So d square by dx square is capital D square minus of a plus b into capital D. So this equation can be written as capital D square minus of a plus b into capital D, and what is the next one? Plus ab totally y is equal to e power ax plus e power bx. Okay, so this is consider equation 1. Operator form is equation 1 and is homogeneous or non-homogeneous? Observe clearly. Is a non-homogeneous differential equation. So what is the non-homogeneous differential equation form? So equation 1 is of the form. Equation 1 is of the form. Yes, what is the non-homogeneous standard form? Non-homogeneous standard form is f of d into y is equal to q of x. F of d into y is equal to q of x. Now compare this equation 1 with this standard form where f of d. What is the f of d? F of d is equal to d square minus of a plus b into capital D plus ab. And what is the q of x? Here q of x given, which is equal to e power ax plus e power bx. Two terms. And is a non-homogeneous differential equation. General solution of non-homogeneous differential equation contains two parts. What is the first part? Complementary function. Complementary function. Yes, what is a complementary function? How to find out the complementary function? Is nothing but general solution of homogeneous differential equation. How to write the general solution of homogeneous equation? Consider equation. What is the auxiliary equation? F of m is equal to 0. So auxiliary equation is f of m equal to 0, which is obtained by replacing d by m in f of d. So how to write this is auxiliary equation? M square minus of a plus b into m plus ab is equal to 0. So solve this equation and find the roots. So how to write? From this, first split the terms here, m square minus am minus bm plus ab is equal to 0. So from the first two terms, if we take m is outside, so that is m into m minus a. Again from the next two terms, if we take minus b is common, so that is m minus a is equal to 0. Yes, what are the factors here? Factors are, here factors are m minus a into m minus b is equal to 0. m minus a into m minus b is equal to 0. So here what are the roots? From these two factors, roots are m is equal to a comma b. When the roots are a comma b, here roots are real and distinct. Real and distinct. When the roots are real and distinct, how to write the complementary function? So therefore, complementary function is yc is equal to, so when the roots are real and distinct, yc is equal to c1 into e power ax plus c2 into e power bx. So let us take is equation 2. This is the first part of the general solution. What about next part? Next one is particular integral. Particular integral. Yes, what is a particular integral? First, what is the definition of particular integral? Particular integral, from the definition, particular integral is yp is equal to 1 by f of d into q of x. Now here q of x is e power ax plus e power bx. That means q of x contains two terms. So which is equal to, first write the q of x. What is the q of x? E power ax plus e power bx. When q of x contains multiple terms, better to split this particular integral. So how to write? Which is equal to 1 by f of d into e power ax plus 1 by f of d into e power bx. And see here, consider one by one term. So first, consider 1 by f of d into e power ax. So let us take this is equal to yp1 plus yp2. So particular integral first part, second part. So consider yp1. So that is equal to yp1. Yes. How to find out this particular integral? Observe clearly here. What is the x coefficient? Is a. And this is equal to 1 root. Listen careful. So here x coefficient is a, which is equal to 1 root of the auxiliary equation. When it is equal to 1 root of the auxiliary equation, if we replace d by a in f of d, then functional value is equal to 0. So here yp1 is equal to, how to write? X by f dash of a into e power ax. Why I am writing directly x by f dash of a? Here, since what is the condition? Condition is f of a is equal to 0. When functional value is equal to 0, so follow the first step. What is the first step? X by f dash of a into e power x. What is the f dash of a? First differentiate f of d and then replace d by a. So here, since, what is the f of d? F of d is equal to d square minus of a plus b into d plus ab. So this is f of d. And what is the f dash of d? F dash of d is equal to 2d. Differentiation of d square is 2d minus a plus b into differentiation of d is 1. So this is the f dash of d. And if we replace d by a, so f dash of a. What is the f dash of a? That means replace just d by a in f dash of d. 2a minus of a plus b. So that is equal to 2a minus a minus b. So this is f dash of a. Now how to write the yp1? So yp1 is equal to, so therefore yp1 is equal to x by f dash of a is a minus b into e power ax. X by a minus b into e power ax. Again, consider yp2. So what is a yp2? Yp2 is 1 by f of d into e to the power bx. Observe clearly. See here, what is the x coefficient? X coefficient is b, and which is equal to 1 of the root. Which is equal to 1 of the root. When x coefficient is equal to 1 of the root, what is the condition? Functional value. That means f of b is equal to 0. So when f of b is equal to 0, how to write the particular integral? Particular integral is x by f dash of b into e power bx. Already we know that f dash of d. What is the f dash of d here? 2d minus of a plus b. So from this equation, what is the f dash of b? F dash of b is equal to 2 into b minus of a plus b. So which is equal to 2b minus b, that is equal to b minus a. So here what is the f dash of b is equal to b minus a. So which is x by b minus a into e to the power bx. Why I am writing this formula x by f dash of b? Here what is the condition? Since f of b is equal to 0, without substituting value in given f of d, how to write this f of b is equal to 0? What is the key point here? X coefficient is b, which is equal to 1 of the root. So that's why its functional value is equal to 0. When it is equal to 0, what is the particular integral formula? X by f dash of b. So this is x by b minus a into e power bx. So therefore, what is the complete particular integral? Yp is equal to yp1 plus yp2. What is the yp1? X by a minus b into e power ax, next plus x by b minus a into e power bx. What is the common term? If we take x by a minus b is outside, what is the remaining term? E power ax. If you take minus sign from this denominator, is e power bx. This is the particular integral, not a general solution. Next we have to write the general solution. So yes, what is the general solution here? General solution is, therefore, general solution of equation 1 is, what is the general solution? Y is equal to complementary function plus particular integral is equal to, yes, what is the complementary function here? See here, complementary function is c1 into e power ax plus c2 into e power bx. So complementary function is c1 into e power ax plus c2 into e power bx plus particular integral. What is the particular integral? X by a minus b, x by a minus b into, yes, what is the remaining term? E power ax minus e power bx, which is the required general solution of a given differential equation. This is a 5 marks question. And observe clearly, in this general solution we have 2 arbitrary constants and order of the given differential equation is also 2. And particular integral does not contains any arbitrary constants. So this is the solution of a given differential equation. This is the solution part. Next, find the particular integral. This is the short answer question, only particular integral. See the question, find particular integral of d square minus d minus 2 into y is equal to e power 2x. What is the particular integral? And first of all, this equation is of the form f of d into y is equal to q of x. Here f of d, where f of d, what is f of d? F of d is equal to d square minus d minus 2. And what is the q of x? Q of x is equal to e power 2x. What is the a value here? X coefficient gives a. So here what is the a value? A is equal to 2. So to find the particular integral, what is the definition of particular integral? Therefore, particular integral is equal to, definition is 1 by f of d into q of x. What is the f of d? So first, before going to write f of d, first check that functional value is equal to 0 or not equal to 0. So since, what is the f of d? F of d is equal to d square minus d minus 2. And what is the f of 2? Here x coefficient is to find f of a value. Before going to write the particular integral, check this condition. F of 2. F of 2. 2 square is 4 minus 2 minus 2. So 4 minus 4 is equal to 0. Here 4 minus 4 is equal to 0. So when functional value is equal to 0, how to write the particular integral? So therefore, particular integral is, which is equal to x by f dash of 2. X by f dash of 2 into e power 2x. Again check that this f dash of 2 is equal to 0 or not equal to 0. So if it is not equal to 0, this formula is not applicable. Check it. So what is the f of d? F of d is equal to d square minus d minus 2. And what is the f dash of d? F dash of d is equal to 2d minus 1. F dash of d is equal to 2d minus 1. And what is the f dash of 2? F dash of 2 is equal to 2 2 is a 4 minus 1. 3 is not equal to 0. When f dash of 2 is not equal to 0, this is the right formula, correct formula for the particular integral. So what is the formula? X by f dash of 2 into e power 2x. Here write since f dash of 2 is not equal to 0. When it is not equal to 0, and write its functional value x by. From this condition, what is the f dash of 2? 3. X by 3 into e power 2x. What is this value? Particular integral. Here we need only particular integral. This is the required particular integral of a given differential equation. Next, method 2. So what is the method 2? When q of x is equal to sin ax or cos ax. So what is the first definition of particular integral? And suppose consider q of x equal to sin ax. What is the particular integral definition? 1 by f of d into sin ax. So here in this particular case, when q of x equal to sin ax or cos ax, consider only d square. F of d is a polynomial in d. Now here consider only polynomial in d square, even powers of d only. That means d square is the least term. Consider polynomial in d square. So next, so after considering only even powers, what is the substitution? So here replace d square by minus a square. So what is the particular integral? Particular integral is equal to 1 by f of minus a square into sin x. When we write this one as a particular integral, provided f of minus a square is not equal to 0. This is the important condition. So f of minus a square is not equal to 0. Then what is the particular integral? 1 by f of minus a square into sin x. What is the transformation here? Put d square is equal to minus a square, not minus a whole square. D square is equal to minus a square. Next, suppose this condition f of minus a square is equal to 0. Suppose f of minus a square equal to 0, then how to write the particular integral? Same, x by f dash of minus a square. So that means find f dash of d and replace d square by minus a square. So f dash of minus a square. When we write this formula, provided f dash of minus a square is not equal to 0. These conditions are important. If these are equal to 0, particular integral does not exist. That's why carefully check these conditions is equal to 0 or not equal to 0. So this is the particular integral when denominator f dash of minus a square is not equal to 0. What happened when f dash of minus a square equal to 0? So when f dash of minus a square equal to 0, then how to write the particular integral? X square by f double dash of minus a square into sin ax. What is the condition? F double dash of minus a square is not equal to 0. So continue this procedure. So in general, suppose rth derivative of f of minus a square equal to 0. So how to write the particular integral? X power r plus 1 by r plus 1th derivative of f of minus a square into sin x. Here also denominator r plus 1th derivative is not equal to 0. So continue this procedure until the denominator will be constant. So here what is the observation? Just replace d square by minus a square. But f of d is a polynomial in d. After replacing d square by minus a square, suppose f of d contains d terms. In this case, how to solve it? So what is the important note? So if after replacing d square by minus a square, f of d contains the terms of d, then denominator is rationalized to obtain the even powers of d. So even power of d. So when denominator contain even power of d, what is our substitution? D square by minus a square. So continue this procedure until the denominator will be constant. So this is the second method procedure. Here what is the key point? Substitution d square by minus a square. Yes, so these are some questions. See here. What is a particular integral? What is a particular integral of d square plus 9 into y is equal to cos 3x? So is a non-homogeneous equation. If we consider is equation 1 is of the form. Equation 1 is of the form. Is of the form f of d into y is equal to q of x. Here, what is f of d? Where f of d is equal to d square plus 9 and q of x. What is the q of x? Q of x is equal to cos 3x. And after identifying the q of x is cos 3x, is of the form cos ax. What is the a value here? A is equal to 3. So next, what is the particular integral? Here what is the question? What is the particular integral of? So what is the particular integral definition? From the definition of particular integral, we can write particular integral as 1 by f of d into q of x. 1 by f of d into q of x. Now here consider only d square terms. So before going to write the particular integral formula, first check that after replacing d square by minus a square, that functional value is equal to 0 or not equal to 0. Here, what is the a value? A is equal to 3. So put d square is equal to minus 3 square, not minus 3 whole square, that is minus 3 square. If d square equal to minus 3 square, that is equal to minus 9 in f of d. So, what is the f of d? So, therefore, f of d is equal to d square. What is the d square is equal to? Minus 9. Minus 9 plus 9 is equal to 0. This condition is important. So, when functional value is equal to 0, so what is the particular integral? So, therefore, particular integral is yp is equal to x by f dash of d or x by f dash of minus a square. But here we have only one d square, x by f dash of d into cos 3x. But what is the f dash of d? Is equal to x by. If f of d is equal to d square plus 9, what is the f dash of d? F dash of d is equal to 2d. Differentiation of d square is 2d and differentiation of 9 is 0. So what is the denominator? 2d into cos 3x. So that is what is the particular integral? Yp is equal to x by 2d into cos 3x. Now observe clearly. What is a d? What is a d? Capital D definition is d by dx. D by dx is nothing but is a differentiation. So capital D is the differential operator. So what is its inverse? D inverse. D inverse is nothing but 1 by d. So what is the antiderivative? So that is called integration. So integration of dx. Now here which is equal to x by 2 into 1 by d into cos 3x. After replacing d square by minus a square, if f of d contains d terms, here we have only one d. So no need to multiply and dividing with d. So directly integrate it. So 1 by d into cos 3x, x by 2 into integration. 1 by d into cos 3x is nothing but integration of cos 3x into dx. What is the integration of cos 3x? That is equal to x by 2 into integration of cos is sine 3x by 3. So total what is the particular integral? X by 6 into sine 3x. X by 6 into sine 3x. We have here some direct formula when. So particular integral of 1 by d square plus a square into cos ax. 1 by d square plus a square. If denominator is only in this form, d square plus a square. 1 by d square plus a square into cos x. Here if you observe clearly, after replacing d square by minus a square, here denominator is equal to 0. So how to write? 1 by d square plus a square into cos ax is equal to, we have direct formula, x by 2a into sin ax. X by 2a into sin ax. Similarly, particular integral of 1 by d square plus a square into sin ax. D square plus a square into sin ax is equal to minus x by 2a into cos ax. Minus x by 2a into cos x. These formulas from this derivation part only. So direct formula when the denominator is d square plus a square. In both the cases d square plus a square. When q of x equal to cos ax, it is x by 2a into sin x. When q of x equal to sin ax, it is minus x by 2a into cos ax. So this is the required particular integral. So therefore, what is the particular integral? Particular integral is equal to x by 6 into sin 3x. This is the required particular integral of a given differential equation. Next, solve. D square minus 4 into y is equal to 2 cos x. D square minus 4 into y equal to 2 cos x. Observe question clearly. Solve means we have to find the general solution. So, is which equation? Is a non-homogeneous equation. If it is a non-homogeneous equation, its general solution contains two parts, complementary function and particular integral. So, first write the standard form. So, equation 1 is of the form f of d into y is equal to q of x. F of d into y is equal to q of x. Where? What is f of d? Compare equation 1 with the standard form. Where f of d is equal to d square minus 4. F of d is equal to d square minus 4. And what is the q of x? Q of x is equal to 2 cos x. And what is the a here? Is of the form cos ax. What is the a here? A is equal to 1 only. X coefficient is 1. Next, is a non-homogeneous equation. So, general solution contains complementary function plus particular, general solution is complementary function plus particular integral. So, first one is complementary function. So, complementary function is nothing but general solution of homogeneous differential equation. We know that how to find out the general solution of homogeneous equation by considering auxiliary equation. So, consider auxiliary equation. What is auxiliary equation? F of m is equal to 0. What is f of d here? T square minus 4. What is the f of m? F of m is m square minus 4 is equal to 0. So, if we write the factors, so that is m plus 2 into m minus 2, that is m is equal to plus or minus 2. After finding the roots, write its nature to write the complementary function. Here, roots are real and distinct. Real and distinct. When the roots are real and distinct, what are the roots? Plus 2 and minus 2. When the roots are real and distinct, so therefore, complementary function is equal to yc is equal to, how to write? C1 into e power minus 2x plus C2 into e power 2x. You can also write c1 into e power 2x plus c2 into e power minus 2x. That order is not a matter. Okay. So, this is the complementary function. This is the complementary function. And next, find the particular integral. So, what is a particular integral? Particular integral. First, write the definition. So, what is the side heading? Particular integral. So, what is a particular integral definition? Yp is equal to 1 by f of d into q of x. 1 by f of d into q of x. So, now observe clearly. Here what are the roots? Plus or minus 2. Okay. And here what is the a value? In a q of x, what is the a value is equal to 1. When the roots are here, one important key point is there. When the roots are real and q of x is sin ax or cos ax, here after substituting d square by minus a square, here denominator is non-zero. Check it. So, what is the f of d? F of d is equal to d square minus 4. And what is the a value? A is equal to 1. Put d square is equal to minus 1 square, that is equal to minus 1. If we substitute d square equal to minus 1 in f of d, so then we get f of d is equal to d square is equal to minus 1 minus 4 is equal to minus 5 is not equal to 0. What is here key point? When the roots of the auxiliary equation are real and q of x is sin ax or cos ax, if we replace d square by minus a square in f of d, now here that functional value is non-zero. That is a non-zero. Without checking the condition, directly we can write the particular integral formula. So, how to write? So, therefore, yp is equal to 1 by f of minus 1 square into 2 cos x into 2 cos x. So, what is the f of minus 1 square? F of minus 1 square. So, already calculated, that is equal to minus 5. So, 1 by, that means replace d square by minus 1 square, not minus 1 whole square. So, minus 1 square is not equal to minus 1 whole square. Minus 1 square. So, that is equal to minus 1 by 5 into 2 cos x. So, what is the answer? Which is equal to minus 2 by 5 into cos x. This is the particular integral. So, next write the general solution. What is the general solution? So, therefore, general solution of equation 1 is, so how to write the general solution? Y is equal to yc plus yp. What is a yc? So, here what is a complementary function? Complementary function is c1 into e power minus 2x plus c2 into e power plus 2x. c1 into e power minus 2x plus c2 into e power plus 2x plus, what is a particular integral? Particular integral is equal to minus 2 by 5 into cos x. Rewrite this one. So, that implies y is equal to c1 into e power minus 2x plus c2 into e power plus 2x minus 2 by 5 into cos x, which is the required general solution of a given differential equation. So, this is the solution. Next, solve. dq plus 4d into y is equal to 5 plus sin 2x. So, is a non-homogeneous differential equation. First, compare the given equation with the standard form. So, equation 1 is of the form. Equation 1 is of the form f of d into y is equal to q of x. F of d into y is equal to q of x. Dear students, find the complementary function and post your answer in chat box. So, here what is a f of d? Where f of d is equal to d cube plus 4d. And what is a q of x? Here q of x contains two terms. Q of x is equal to 5 plus sine 2x. 5 plus sine 2x. So first, write the complementary function. So what is the complementary function? First, to write the complementary function, consider auxiliary equation. What is the auxiliary equation? Consider auxiliary equation. So auxiliary equation is f of m is equal to 0. So that is, already we know that f of d, and what is the f of m? F of m is m cube plus 4m is equal to 0. So that implies if we take m is outside, so m square plus 4 is equal to 0. So from this one, what are the roots? Factors m and m plus 2i and m minus 2i. So m equal to 0 comma plus or minus 2i. So from this one, m equal to 0, and from the next factor, m square plus 4 equal to 0, which gives m is equal to plus or minus 2i. So here 3 roots are there. So out of 3 roots, 1 is real and 2 roots are complex and distinct. So how to write the complementary function? So here, of which one root is, clearly write the nature. So one root is real and 2 roots are complex and distinct. 2 roots are complex and distinct. When we know the nature, then it is very easy to write the complementary function. So therefore, complementary function is equal to yc is equal to, first, corresponding part of the real root. So that is c1 into e power 0x. And observe clearly in a complex roots which is of the form alpha plus or minus I beta. Now here what is the alpha value? 0. Beta value 2. And so how to write the corresponding part of the complex roots? That is plus e to the power alpha x. What is alpha here? 0. E power 0x into next c2 into cos beta x. What is the beta? Beta is equal to 2. c2 into cos 2x plus c3 into sin 2x. But in both the cases, what is the e power 0 is 1. So how to write the first term? c1 plus e power 0 is 1. Next two terms, c2 into cos 2x plus c3 into sin 2x. What is this value? This is the complementary function yc. yc is equal to c1 plus c2 cos 2x plus c3 sin 2x. Here how many arbitrary constants are there? 1, 2, 3. And what is the order of the given differential equation? 3. So in complementary function, in a number of arbitrary constants only in complementary function. So particular integral does not contains any arbitrary constant. So that's why complementary function contains total number of arbitrary constants. So this is the complementary function. Next, write the particular integral. So how to find the particular integral? So what is the definition of particular integral? So first, yp is equal to, definition of particular integral is 1 by f of d into q of x. Now write here 1 by, before going to write the f of d, first here q of x contains more than one term. So to split the terms, particular integral, first write q of x 5 plus sin 2x. And first split it, which is equal to 1 by f of d into 5. Now here write phi coefficient as either e power 0x or cos 0x. That is our choice. So better to consider it is exponential, e power 0x plus 1 by f of d into sin 2x. Now in a second term, what is the a value here? A is equal to 2. So consider which is equal to yp1 plus yp2. Consider 1 by 1. So now yp1 is equal to, what is the yp1? yp1 is equal to 1 by f of d into 5 into e power 0x. Now here what is the a value? A is equal to 0. Observe clearly. Already I told this condition. In a first particular integral, a is equal to 0. Now here what are the roots? 0 plus or minus 2i. When a is equal to one of the root, if we substitute d is equal to 0, that means d equal to a, here what is the a value? A equal to 0, in f of d functional value is 0. So that means initial case not applicable. So in this case how to write that one? So that is 5 into x by f dash of 0. X by f dash of 0 into e power 0x is 1. No need to write this one, e power 0x. Why I am writing this formula? Here what is the condition? Condition is, since f of 0 equal to 0, without substituting, how to say that condition? Observe clearly. Here a equal to 0, that is equal to one of the root. So therefore functional value f of 0 is always is equal to 0. When denominator is equal to 0, go for first step. What is the first step? X by f dash of 0 into e power 0x. How to write f dash of 0? Since what is the f of d? F of d is equal to d cube plus 4d. So f of d is equal to d cube plus 4d. What is the f dash of d? F dash of d is equal to differentiation of d cube is 3d square plus differentiation of 4d is 4. Now what is the f dash of 0? F dash of 0 is equal to 4, which is not equal to 0. Suppose this a is equal to 0 and which is equal to one of the root and is repeated 2 times. In that case f of 0 equal to 0 and f dash of 0 is also is equal to 0. In that case apply the second step, that means x square by f double dash of a. Here first step is applicable, so f dash of 0 equal to 4, which is not equal to 0. Therefore what is the particular integral? Yp1 is equal to 5x by, what is the f dash of 0? 4. E power 0x is 1 only. No need to write that condition here. What is the yp1? 5 by 4 into x. You can also consider in place of e power 0x, consider cos 0x also. That is our choice. But instead of cos, better to consider exponential. This is my opinion. Next, consider yp2. What is a yp2? Consider yp2. Yp2 is equal to 1 by f of d into sin 2x. 1 by f of d into sin 2x. And observe clearly, see here. What are the roots? Roots are, out of 3 roots, 1 is real. So when q of x is equal to either sin x or cos x and the roots are real, if we replace d square by minus a square, the denominator is not equal to 0. This is one important key point, without substituting the value in given f of d. So now here what is the f of d? F of d is equal to d cube plus 4d. So which is equal to 1 by d cube plus 4d into sin 2x. What is the a value here? Since a is equal to 2. When a is equal to 2 and if q of x equal to sin x or cos x, what is our substitution? D square is equal to minus a square. So put d square is equal to minus 2 square, not minus 2 whole square, that is minus 2 square. Minus 2 square is minus 4. So therefore particular integral yp2 is equal to 1 by, substitute only in d square, not in d. So how to write d cube? D cube can be written as d into d square. But what is a d square? D square is equal to minus 4d plus, sorry, so d square, d into d square is equal to minus 4 plus 4d. and solve this one in another form. Yes. So, from this one take d is outside, that is equal to d square plus 4 into sin 2x. D square plus 4 into sin 2x. So, already I told that what is the formula? 1 by d square plus a square into d square plus a square into sin ax. What is the d square plus a square into sin ax is equal to minus x by 2a into cos ax. Just apply that formula. So, that is equal to 1 by, first rewrite this one, 1 by d into 1 by d square plus 4 into sin 2x. D square plus 4 into sin 2x, that is equal to, yes, that is equal to 1 by d into, yes, here a is equal to 2 square. So, what is the formula? Minus x by 2a, 2 into 2, 4 into cos 2x, that is equal to cos 2x. Again rewrite this one, which is equal to minus 1 by 4 into 1 by d into x into cos 2x, x into cos 2x. When d is the differential operator, when d is the differential operator, what is the 1 by d? 1 by d is integration. Now here how to write this value? So, that is equal to, so which is equal to minus 1 by 4, minus 1 by 4 into. So, this 1 by d into cos 2x can be written as integration of x into cos 2x into dx, x into cos 2x into dx. Now, here apply the integrating by parts uv. Already in the last class I told that what is the formula. So, minus 1 by 4 into u. What is the u? X. v1. What is integration of cos 2x? Integration of cos 2x is sin 2x by 2 minus u dash. What is the differentiation of x? Differentiation of x is 1 into v2. So, integration of v1. So, integration of sin 2x. Integration of sin 2x is minus cos 2x by 2. Already we have 1, 2, that is equal to 4. U double dash. Differentiation of 1 is 0. So, no need to take the other terms. So, which is equal to minus 1 by 4 into x by 2 into sin 2x, minus into minus plus cos 2x by 4. Cos 2x by 4. So, this is the yp2. Now, what is the yp? So, therefore, yp is equal to yp1 plus yp2. So, what is the yp1? 5x by 4. So, yp1 is equal to 5x by 4 and yp2 is equal to minus 1 by 4 into or minus 1 by 4 into x by 2 into sin 2x plus cos 2x by 4. This is the particular integral. At last, write the general solution. What is the general solution? So, general solution of given equation. General solution of equation 1 is y is equal to yc plus yp. So, what is the yc? c1 plus c2 cos 2x plus c3 sin 2x plus particular integral. What is the particular integral? 5x by 4 minus, if you take 2 or right as it is, 1 by 4 into x by 2 into sin 2x plus cos 2x by 4. So, which is the required general solution of a given differential equation. This is the solution, general solution of a differential equation. Next question, solve. D square minus 2d plus 2 into y equal to sin x plus e power 2x. So, consider is equation 1. Is a non-homogeneous and here particular integral, here q of x contains two different terms. In this case, how to find out the particular integral? See here, equation 1 is of the form. Equation 1 is of the form f of d into y is equal to q of x. Dear students, find the complementary function. Compare the given equation with this standard form. Where what is f of d? F of d is equal to d square minus 2d plus 2. And what is the q of x? Q of x is equal to sin x plus e power 2x. Sin x plus e power 2x, it contains two different terms. So first is a non-homogeneous equation. First we have to find the complementary function. So to find the complementary function, consider auxiliary equation. So what is the auxiliary equation? F of m is equal to 0. What is the f of m? Here, which is m square minus 2m plus 2 is equal to 0. Here we are unable to write the product of the factors. So how to find out the roots? M is equal to, apply the formula minus b plus or minus root over b square minus 4ac by 2a minus b. So minus into minus 2 plus or minus root over b square 4 minus 4ac, 4 2 is 8 by 2. So which is equal to minus into minus plus 2 plus or minus 4 minus 8 minus 4, root minus 4 is 2i by 2. So which is equal to 1 plus or minus I. So what is the nature? Roots are complex and distinct. Roots are complex and distinct. What is the standard form of this one? Alpha plus or minus I beta. Here alpha is equal to 1 and beta is equal to 1. When the roots are complex and distinct, how to write the complementary function? So therefore, complementary function of equation 1 is yc is equal to, when the roots are complex and distinct, what is the formula? E power alpha x. What is the alpha? 1. So e power x into c1 cos beta x. What is the beta? 1. So that is c1 cos x plus c2 sin x. E power x into c1 cos x plus c2 sin x. So this is the complementary function. That means first part of the general solution. Next, how to find out the particular integral? So here particular integral can be written as, first write the definition. What is the particular integral definition? Yp is equal to 1 by f of d into q of x. When q of x contains more than one term, so here first split particular integral. So that is equal to 1 by f of d into, what is the q of x? Q of x is equal to sin x plus e power 2x. Sin x plus e power 2x. Split it 1 by f of d into sin x plus 1 by f of d into e power 2x. Consider this one as first part of the particular integral and second one is second part of the particular integral. So why I am splitting this one into two parts here? These two are the different forms. Q of x is, one is sin x and another one is exponential. So that's why before going to write the formula, first split the particular integral and calculate one by one. So consider yp1. Consider yp1. What is a yp1? Yp1 is 1 by f of d into sin x. What is the a value here? A is equal to 1. So when a is equal to 1 and what is the f of d? 1 by d square minus 2d plus 2 into sin x. So When q of x equal to sin x, what is the substitution term? Put d square is equal to minus a square. So put d square is equal to minus 1 square, that is equal to minus 1. So therefore, yp1 is equal to 1 by, if we substitute d square is equal to minus 1, minus 1 minus 2d plus 2 into sin x. So now here which is equal to 1 by minus 1 plus 2, 1 minus 2d into sin x. Now how to find the particular integral here? After substituting d square by minus a square in f of d, if f of d contains again d terms, in this case how to find the particular integral? Make denominator even power. When it will be even power? By rationalize it. So what is the conjugate of 1 minus 2d? That is equal to 1 plus 2d by 1 minus 4d square, multiply and dividing with 1 plus 2d. So into sin x. When denominator contains even power, what is our substitution? D square is equal to minus a square. Again put d square is equal to minus a square. So that is 1 minus 4 into minus 1 into sin x. Put d square is equal to minus 1 square, that is equal to minus 1. So what is the denominator here? 1 minus into minus plus 4. So denominator is a constant. So 1 by 5 into 1 plus 2d into sin x is not a particular integral because here differential coefficient is there. So how to find out that one? Operate the sin x with 1 plus 2d. What is a capital D? Is a differential operator. So how to operate this one? 1 by 5 into 1 into sin x plus 2 into d into sin x. What is a capital D? Is a differential operator. That means differentiation of sin x. What is the differentiation of sin x? Cos x. This is the yp1. So which is equal to yp1. First part of the particular integral completed. Next, what is the second part? 1 by f of d into e power 2x. So consider yp2. What is the yp2? 1 by f of d into e power 2x. And here what is the a value? A is equal to 2. Here what is the substitution? Observe clearly. Here this function is exponential. Don't substitute d square by minus a square. Here what is the substitution? D is equal to a. It follows method 1. So what is the f of d here? F of d is equal to d square minus 2d plus 2. D square minus 2d plus 2 into e power 2x. What is the a value here? 2. And what are the roots of the auxiliary equation? Roots of the auxiliary equation are complex. So that a is not equal to any one root. So when a is not equal to any one root, so therefore what is the yp2? Yp2 is equal to 1 by f of 2 into e power 2x. Why I am writing directly f of 2 here? Since f of 2 is not equal to 0. Check that one. So what is the f of d? Since f of d is equal to d square minus 2d plus 2. So when f of d is equal to d square minus 2d plus 2, and what is the f of 2? F of 2 is equal to 2 square is 4 minus 2 into 2, 4 plus 2. So minus 4 plus 4 get cancelled. We get only 2, that is not equal to 0. So therefore what is the yp2? Yp2 is equal to, so this is the reason. So what is the f of 2? So f of 2 is equal to 2, 1 by 2 into e power 2x. So this is the second part of the particular integral. Now write combined particular integral. So total particular integral. Therefore yp is equal to yp1. So what is the yp1? Yp1 is equal to 1 by 5 into sin x plus 2 cos x. 1 by 5 into sin x plus 2 cos x. Next, what is the yp2? Yp2 is equal to 1 by 2 into e power 2x. This is the complete particular integral. Now write the general solution. What is the general solution? Therefore, general solution of equation 1 is y is equal to yc plus yp, complementary function plus particular integral. So what is a yc? Yc is equal to e power x into c1 cos x plus c2 sin x plus yp. What is a yp? Yp is equal to 1 by 5 into sin x plus 2 cos x plus 1 by 2 into e power 2x, which is the required general solution. These are the long answer questions, ma. This is the required general solution of a given differential equation. Next, when q of x is equal to x power m or polynomial in x. So this is the third method to find the particular integral where m is a positive integer only. So here first, what is the definition of particular integral? 1 by f of d into q of x. What is the q of x here? X power m. So 1 by f of d into x power m. When q of x is equal to x power m, how to write the particular integral? Now here reduce f1 by f of d. So how to reduce? So to evaluate particular integral, reduce 1 by f of d to the form 1 by 1 plus or minus phi of d. Observe clearly here first coefficient, first term is 1. 1 by 1 plus or minus phi of d. When it will come by taking lowest degree term from f of d. So if we take the lowest degree term from f of d, then 1 by f of d becomes 1 by 1 plus or minus some function of d. Let us denote that is pi of d. So after writing that one, so write 1 by f of d as 1 plus or minus phi of d whole inverse. And using the binomial expansion, expand this one in ascending powers of d. So is an infinite series. Expand up to the term containing d power m only. Up to the term containing d power m. Because d power, if we take the another terms, d power m plus 1 into x power m is equal to 0. M plus 1 times differentiation of x power m is 0. Because m times of differentiation of x power m is m factorial. M factorial is constant. Again if we differentiate that constant, we get 0. So that's why expand this 1 plus or minus phi of d whole inverse in ascending powers of d up to the term containing d power m. This is the procedure and some useful expansions. So these are the some useful expansion, binomial expansions. Yes. How to solve this differential equation? So consider is equation 1 and equation 1 is of the form. So equation 1 is of the form f of d into y is equal to q of x. Where what is f of d? F of d is equal to d square plus phi d plus 4. And what is the q of x? Q of x is equal to x square. Observe clearly, particular integral is depending on q of x only. So when q of x equal to x square, how to find out the particular integral? Before that one, first write the complementary function. So what is the complementary function? To write the complementary function, consider auxiliary equation. What is the auxiliary equation? F of m is equal to 0. So f of m is equal to 0. So what is the f of m? That is m square plus 5m plus 4 is equal to 0. So this is 4 ones. What are the factors? How to write? M square plus 4m plus m plus 4 is equal to 0. 4m square, 4 ones. So if we take m is common from the first two terms, m plus 4 plus 1 is common. From the next two terms, m plus 4 is equal to 0. What are the factors? Factors are m plus 4 into m plus 1 is equal to 0. So if these are the factors, then what are the roots? M is equal to minus 1 comma minus 4. When the roots are minus 1 and minus 4, what is the nature? So here the roots are real and distinct. Real and distinct. When the roots are real and distinct, how to write the complementary function? So therefore, complementary function is yc is equal to c1 into e power minus x plus c2 into e power minus 4x. This is the first part of the general solution. Next, how to find the particular integral? So what is the particular integral? Yp is equal to, first write the definition, 1 by f of d into q of x. Yes, what is the f of d here? 1 by d square plus 5d plus 4 into q of x is equal to x square. In first two methods there is substitution, but in the third method there is reduction. So here, what is the procedure? So reduce this 1 by d square plus 5d plus 4 into the form of 1 by 1 plus or minus 5 of d by taking out lowest degree term. So here what is the lowest degree term? 4. So take 4 is outside. If we take 4 is outside, how to write this one? 1 plus d square plus 5d by 4 into x square. What is our procedure? Reduce 1 by f of d into the form of 1 by 1 plus or minus function of d. So here 4 is the lowest degree term. If we take 4 is outside, which is 1 plus d square plus 5d by 4 into x square. Again, how to write this one? 1 by 4 into 1 plus d square plus 5d by 4. Consider this is one function, whole inverse x square. So what is the expansion? 1 plus d whole square, 1 plus d whole inverse expansion. 1 plus d whole inverse expansion is 1 minus d plus d square minus d cube plus d power 4, so on. So just apply this formula. Yes. So what is the 1 plus d whole inverse formula? Consider this one is one term, 1 plus one term only. So that is equal to 1 by 4 into. So what is the formula? 1 minus d. So in place of d we have d square plus 5d by 4. Next, plus 1 plus d whole inverse. See here. 1 plus d whole inverse is equal to 1 minus d plus d square minus d cube plus d power 4 minus so on. So that is the formula. So 1 minus d plus d square. So what is the d square? D square plus 5d by 4 whole square. No need to take other terms. Okay na? If we take higher terms, so that differentiation of x square is equal to 0. Here what is the m? Only 2. So that's why take up to d square only into x square. So which is equal to 1 by 4 into. First simplify the inside terms. So 1 minus 1 by 4 into d square plus 5d plus 1 by 4 whole square, that is equal to 1 by 16. If we expand d square plus 5d whole square, d square whole square is d power 4. So first differentiation of x square is equal to 2x. Next, 2 times the differentiation of x square, that is differentiation of 2x is equal to 2. Next, d cube of x square, that is differentiation of 2 is equal to 0. Okay. See here, d square whole square, d power 4. So fourth derivative of x square is 0. So neglect the higher degree terms. Next, plus 2ab. So 2 into d square into 5d, that is equal to 10d cube. So what is the differentiation of 3 times the differentiation of x square is 0. Neglect the term also. Next, what is the next one is 5d square. So that is equal to 25 into d square, because 2 times the differentiation of x square is 2. So that's why consider that term into x square. Now operate this total expression with x square. So that is equal to 1 by 4 into next x square into 1, x square minus 1 by 4 into. See here, 2 times the differentiation of x square. What is the 2 times the differentiation of x square is 2. Next plus 5 into differentiation of x. Here we have 5d differentiation of x square. What is the differentiation of x square is 2x. That is 2x next plus 1 by 16. That means 25 by 16 into 2 times the differentiation of x square. What is the 2 times the differentiation of x square is 2. Simplify this one, which is equal to 1 by 4 into x square 2 by 4, that is equal to 1 by 2. Next minus 2 ones are 2 twos are 5 by 2 into x. Next 2 ones are 2 eights are plus 25 by 8. 25 by 8, which is equal to 1 by 4 into x square minus 5 by 2 into x. Next minus, so 8 minus 4 is 25. So that is equal to plus 21 by 8. This is the particular integral. That is a particular integral. Now write the general solution. So therefore, general solution of equation 1 is y is equal to, yes, what is the general solution formula? Y equal to yc plus yp. So that implies y is equal to, what is a yc? yc is equal to c1 into e power minus x plus c2 into e power minus 4x. c1 into e power minus x plus c2 into e power minus 4x plus yp. What is a yp? Plus 1 by 4 into x square minus 5 by 2 into x plus 21 by 8. So which is the required general solution of a given differential equation, and this is the procedure to find the particular integral when q of x is equal to x square. When q of x equal to x power m, here reduce 1 by f of d to the form 1 by 1 plus or minus phi of d by taking out, when it is 1 plus or minus phi of d, by taking out lowest degree term from f of d. So this is the procedure. Here binomial expansions are important to expand this one in ascending powers of d. So this 1 plus or minus phi of d whole inverse expansion is binomial expansion. So using the binomial expansion, expand it in ascending powers of d. So here binomial expansions are important. Next, solve d square plus 4 into y is equal to cos square x plus x power 4. Here also q of x contains two different terms. So first, if it is equation 1 is of the form f of d into y is equal to q of x, where what is f of d? Where f of d is equal to d square plus 4, and what is the q of x? Q of x is equal to cos square x plus x power 4. So first, to write the general solution, first find the complementary function. So to find the complementary function, consider auxiliary equation. So what is the auxiliary equation? Auxiliary equation is f of m is equal to 0. So what is the auxiliary equation? That implies m square plus 4 equal to 0. What are the roots? Roots of this auxiliary equation are m is equal to plus or minus 2i. So is of the form alpha plus or minus I beta. So roots are, what is the nature? Roots are complex and distinct. When the roots are complex and distinct, how to write the general solution? Here alpha is equal to, how to write the complementary function? So therefore yc is equal to e power alpha x. What is alpha? If we compare these two, alpha is equal to 0 into c1 cos beta x. What is a beta? 2. Beta is equal to 2. c1 into cos 2x plus C2 into sine 2x. But what is the e power 0? E power 0 is equal to 1. So how to write this one? Yc is equal to C1 cos 2x plus C2 sine 2x. This is the complementary function. Next, how to find out the particular integral? Yes. What is the particular integral definition? Yp is equal to 1 by f of d into q of x. Here q of x contains two terms. First, 1 by f of d into, what is the q of x? Q of x is equal to cos square x plus x power 4. Split it. 1 by f of d into cos square x plus 1 by f of d into x power 4. So here q of x contains two different terms. Here apply different methods to write the particular integral. So that's why consider which is yp1, second one is yp2. So consider yp1. Consider yp1. So what is the yp1? 1 by f of d into cos square x. Observe clearly, is not in the linear form. When we know when q of x equal to sin ax or cos ax, we have a method. But here we have cos square x. How to write this cos square x? Which is equal to 1 by f of d into cos square x can be written as, write it into linear form, that is 1 plus cos 2x by 2. 1 plus cos 2x by 2. Again this can be written as 1 by 2 into 1 by f of d, okay, into 1 can be written as e power 0x. Here you can write that one as either e power 0x or cos 0x or x power 0x, x power 0. That is our choice. So here I am taking e power 0x plus 1 by f of d into cos 2x. In a second one, what is the a value? Here a is equal to 2. In a first term, what is the a value? 0. Okay. How to write the particular integral? Is equal to 1 by 2 into s. Here a is equal to 0. And what are the roots? Roots are plus or minus 2i, complex roots. That a is not equal to the any root, not equal to roots. So therefore, what is the particular integral? Directly we can write that is equal to 1 by f of 0 into e power 0x plus. Next, what is the f of d? Here f of d is equal to 1 by d square plus 4 into cos 2x. d square plus 4 into cos 2x. And what is the f of 0? F of d is equal to d square plus 4. What is the f of 0 is only 1 by 4. So 1 by 4. And in a second term, observe clearly. So when we when we substitute d square equal to minus a square, minus 4 plus 4 0. We have one direct formula. What is that formula? That is equal to x by 2a, 2 into 2, x by 4 into sine 2x. X by 4 into sine 2x. So which is equal to 1 by 8 into 1 plus x sine 2x. This is the first part of the particular integral. Coming to the second part. What is the second part? yp2. yp2 is equal to 1 by f of d into x power 4. What is the f of d here? d square plus 4 into x power 4. Now here apply reduction process. So what is the lowest degree term here? 4. So if we take 4 is outside, 1 by 4 into, how to write this one? d square by 4 into x power 4. So again how to operate this one, which is equal to 1 by 4 into 1 plus d square by 4 whole inverse into x power 4 and expand that one into ascending powers of d. So how to write? yp2 is equal to 1 by 4 into 1 plus d square by 4. 1 plus d square by 4 whole inverse into x power 4. So, expand it, which is equal to 1 by 4 into. Again, apply the same formula. What is the 1 plus d whole inverse? 1 plus d whole inverse is equal to 1 minus d plus d square minus d cube plus d power 4 minus so on. So, apply that formula. 1 minus d. So, that is 1 minus d square by 4 plus d square by 4 whole square. No need to take the other terms. Since what is the next term? D square by 4 cube. So, that is equal to, that is exceed this power. So, that is why no need to take the higher terms into x power 4 is equal to 1 by 4 into first. Operate this expression with x power 4 minus 1 by 4 into. What is the 2 times differentiation of x power 4? So, first time differentiation of x power 4 is 4x cube. So, second time differentiation of x power 4 is differentiation of 4x cube, that is equal to 12x square. So, what is the 2 times the differentiation of x power 4 is 12x square plus 1 by 16 into d square whole square, d power 4. So, 4 times the differentiation of x power 4 is 4 factorial. So, that is equal to 1 by 4 into x power 4 minus 3x square. 4 factorial is 24. So, 24 by 16. 24 by 16. 8 3s are 8 2s are. So, that is equal to 1 by 4 into x power 4 minus 3x square plus 3 by 2. So, this is the second part of the particular integral. Now, write combined particular integral. So, what is the combined particular integral? So, therefore, yp is equal to yp1. So, what is the yp1? yp1 is equal to 1 by 8 into 1 plus x sine 2x. 1 by 8 into 1 plus x sine 2x. Next, plus yp2 is 1 by 4 into x power 4 minus 3x square plus 3 by 2. Next, write the general solution. So, therefore, general solution is y is equal to yc plus yp. So, what is the yc? yc is here c1 cos 2x plus c2 sin 2x. c1 cos 2x plus c2 sin 2x. Next, what is the yp? 1 by 8 into 1 plus x sin 2x plus 1 by 4 into x power 4 minus 3x square plus 3 by 2. So, which is the required general solution of a given differential equation. So, this is the procedure to find the particular integral. So, direct methods, 3 individual methods completed. In the next session, I will explain remaining direct methods and method of variation of parameters. Thank you everyone.